Hello everyone, welcome to my channel. Today we are going to start proper mathematics with the help of Python, and the first topic would be differentiation. So in this video we are going to discuss differentiation. So if you are from science background or if you are not from science background, then also it will okay. I will explain what is differentiation. So differentiation is just normally, if you have some number, that means suppose you have a speed. If we talk about speed, then we have distance. In mathematics, we know that there's a distance, and then we talk about the distance with respect to time, then it will be velocity. That means in how much time you can reach. Suppose you have a distance of 2 kilometer and you are going to take time, suppose 1 hour. If you are walking, then you are going to take 1 hour to reach 2 kilometer or to cover the distance of 2 kilometers. Actually, in 1 hour you can cover more than 4 5 kilometers. Okay, so suppose in 1 hour you are covering a distance of 4 kilometer. So what would be your velocity or speed? So your velocity or speed would be, or you can say your actually your speed would be the distance which is 4 kilometer and the time which is 1 hour. So distance by time, that means 4 by 1, and it would be 4. That means your speed would be 4 kilometer per hour. So you can see that here we are going to check, or we can see that we are taking the time and also the distance, and we are with respect to time we are deciding that what is your speed. So this is a very simple example of differentiation. That means if time will increase, then your distance will be increased. If distance decreases, your time will be decreased. So this is how we will start differentiation, and this is about differentiation. So differentiation is is nothing but how fast something is changing. It's just showing you. Let me show a picture. So you can see that I have mentioned differentiation how fast something is changing, and I have also taken some distance as x, and you can see that we are going to discuss the velocity. So initially we know that distance is x, then your speed will be x by t. That means, oh, I didn't mention here t, na, let me write over here. So your distance would be, if I mention over here, suppose let me take this one. First, let me close the bracket, and then your speed. If I talk about the speed, then your speed would be, suppose your speed, actually, let me erase this one. Instead of doing, I can simply say, I will write it in the VS code. Okay, now let it be for the time being. Okay, so distance would be your, let's go to the VS code, and here I can write it. Suppose I'm writing over here, I'm giving a comment line, and I'm writing that you have a distance of x. Your distance would be, your distance is x. So what would your speed? Your speed would be x divided by t. What is t? X is your distance and t is time. That means in what time you are covering the same distance. So this will be your speed. So in the same manner, you can define your velocity. So what will your velocity? Suppose your here, if I take not x as a distance, if I take x as a speed, then we can differentiate in this way. That means with the respect of time, I'm going to differentiate x. If I give you a simple example, then it would be like this one. If I have a, suppose I have a function, not let don't talk, let's not talk about the function. So let me, if y equals to x plus 3, And now I'm going to differentiate, and then what will happen with the respect of x? If you want, you can differentiate it with the respect of y. That means you are going to change the value of y, and x, the value of x will reflect based on the value of y. This is simply, let me first derive it with respect of x. So suppose I am going to differentiate it with respect of x, then y will be constant here. Y will be treated as constant, and whenever you are going to differentiate a constant, then the result would be 0. So here, if I write dy, oh wait a minute, I have to give command line. Instead of doing command line, I can do something else. So let me copy this one. Actually, we cut it. So it would be easy for me if I work on it. Or I don't need to take it again. I have already taken. Okay, let it be. I'm taking it again. So now I will use it over here. And let me delete. So now I can work properly. There will be no problem, no issue. Hmm. So I'm going to differentiate it with respect to y. So it will be dy by dx, okay, and equals to x. As we are considering x, I mean we are going to differentiate with respect of x, then what will be the result? Actually, the time when we differentiate with respect of someone, with respect of some variable, so x is a variable, y is also variable, so we are differentiating this equation, we are going to differentiate this equation with respect to x. So here x, you can see the order of x is 1. The order of x is, this is a linear equation, na? The order of x is 1, you can say. And here, as it is the power of x is 1, then this 1 will come in front of x, and the power of x now is 1 minus 1, which is 0. So whenever we the power of any variable would be 0, then it will be 1. So this will, you can say that this will be 1 only. This will be 1. And when you are going to differentiate 3 with respect to x, then it will be nothing but 0. It would be 0. It will give you 0. So the value, the final value would be what? The final value would be dy slash dx, I mean, sorry, equals to 1. This will be the exact value of this equation when we go to differentiate with respect to x. The same thing happen when we will differentiate the same equation with respect to x. Then the answer would be something like this: dx by dy equals to 1. Why? Because that right now I'm going to differentiate it. So here will be dx by dy, and when we're going to differentiate y, then again its value will be 1. So that's why I have written, and 3 will be 0. So this will be your differentiation. Okay, we have already discussed about differentiation very much. Now let's move forward. So if you differentiate it, I mean the speed, then ds by dt would be your dx by dt, and then uh, it will be your velocity. That means if you normally divide your distance by time, then it would be speed, okay, and if you again divide the same speed with time, then it will be velocity, and again if you divide the same thing with time, then it will be acceleration. That means you can say that change of rate of distance will be known as your speed, and change of rate of distance, I mean, sorry, no, not like that, wait a minute. So distance, sorry, distance by change of rate of time, you can say like this one, that if we differentiate distance with respect to time, then it will give you speed, and if we differentiate speed with respect to time, then it will give you velocity, and again if you differentiate velocity with respect to time, then it would be your acceleration. So these are the things, and when we differentiate only one time, then it will be first order derivative, and if you do it the second time, then it will be second order derivative. Suppose I'm going to again differentiate it with respect to time, then what will happen? There will be dq and dtq, then it will be third order derivative. So now we will only discuss about the first order. Okay, so let me give you an example. Over here you can see that I have written y equals to function of x. Okay, and this is nothing but what will happen over here. If you put the value of x, I mean, suppose you have given the value of x as 2. So you can see, suppose this is my question, so y equals to x square, and I'm going to put the value of x as 2, then the value of y would be 4. If I put x value of x is 3, then y would be 9. That means what it is actually going to show you, it's showing you that change in x will reflect y as well. And the I mean, if you increase x as much as, then your y will also increase as much as, very fastly, or faster you can say. So I have just given, and I have shown you a graph like this. I mean, when the value of x would be 2, then the value of y would be 4. Okay, this is a point of 4. Okay, and I have also shown you the derivative which I have did over here, the same thing I did. Okay, the next thing I want to tell you about this equation, this question. This is just let me make you understand this question, then we will discuss it. Here you can see that we have written this in the form of program. So first I'm discussing it like a normal math process. So suppose you have you have function of x equals to x square. Okay, you have a value of function of x, and now you have to find what is function of x plus h minus function of x divided by h. Actually, this is a basic concept of limit, but right now just try to understand it with respect to differentiation. So this will show you actually slope. We are now we are inside this one. Okay. So what would happen? Mm, we have function of x equals to x square. So now you can use it with respect to h also. I mean x plus h also. So instead of x, I will put over here x plus h. Then this will change, and x plus h equals to whole square. It will be x plus h equals to whole square. Okay. So what I and we have this. Okay. Let me use this one. And as you know that we have this equation that we need to solve, the lower one. Okay, this one. This is the main equation that we are going to solve right now. So what will happen? I will put the value which I got from here, function of x plus h equals to x plus h whole square. And we have also function of x. So I'm going to put this value in this equation. So that's why I have written over here the equation, and you can see that function of x plus h minus function of x. So I have put in the value, and you will get the final value of this one. Okay, now if you have value, like I have passed the value as 3 for x, and for h I have given the value as 0.0001. So you can put the value over here, and you will get the answer which we are going to get with this program. Okay, so now let's run this program, and then you will understand what is happening over here. Okay, so first let me run, then I will discuss. So if I go for Python, okay, so you got the value as 6.000000120, like this. So don't go first for this program. Just let's talk about this one. So you know that we have x equals to 3. So if I put x equals to 3 over here, then what will happen? It will be 6. 2 into 3 will be 6, and the value of h is 0.001. So it will be simply 6.001. Hmm. But what is the value of us? It is 6 point. Yeah, you can see 0.001. So this is the same answer you are going to get. Okay. So now let's talk about the programming. So here you can see that I have defined a function called function of x, and it is going to return me x square, because you can see that we have already defined here that x square, we have x square. So it will give me x square, and now I'm passing the value of for x, and also for h equals to 0.001, I mean this value. You can, if okay, I will discuss it later. Right now, let me. Now I'm going to, what I'm going to do, I'm just I have taken an equation and I'm putting it in a reference called derivative, and I am going to print this derivative. So what will happen? So this is going to take, I mean, it will first read that yes, I have function of x, and it is going to return me x square. So it will do the same thing that I did on paper, and the answer that you are getting it. Okay. Instead of doing like this, I can also do it in this way. Hmm. This is the another way you can do it. Like you can see that I have passed a value. I mean, I have defined a function and I have taken, I'm returning x cube, and then I am going to take the slope. And before that, you have to do this one also. If you don't do this, then it will not run actually. Or if you want, yes, let it be. I don't want this one. Rather, I will go for this one. Hmm. So you can see that I have function, and this function value is x square. That means it's going to return me x square. And now I'm going to take the slope. I mean, I want slope. Slope is nothing but, I mean, the line of, this is a line. So you will get this one. So how? I have defined a function called slope, and I'm passing three parameters, f, x, and h. This f is coming from here. Okay, and the value of x that I want to pass, I will write over here. Okay, now, so I have also h given. Actually, h is nothing but, I'm just trying to, you can say that this is tends to 0. It's not 0, but it's very close to 0. So you, if you pass this value as much as, suppose you are passing value 2 for h, then what will happen? X is 3, then it will be 6, and plus 2, it will be 8. This will be, so it will be very high. uh, that's why we are not going to take the value of h as much as, okay, we will take it very near to 0. Hmm. So this function, this slope function, is returning me this equation that I have mentioned here. This function is going to return me this equation, and now I am calling this function with the with I'm passing the value for x. I have already the value of f, which is x square. So it will normally take the value, and the answer will be same. Actually, not same, because here x is 2 and we pass the value of x is. Okay, let me run both program, and then you can understand what is the main difference. So you can see the first is going to give you 4 point. Don't go for other, just learn up to this. I mean, this is your answer. Okay, this would be your answer. So 4.001, and the second one is 6.001, because you pass the value of x h2 in the first case, I mean, here, and in the second case, which is this one, you have passed the value of x as 3. That's why you are getting the 4 and 6. Okay, so this is about it. But actually, why we are discussing differentiation right now? My purpose is to discuss machine learning. I want to show you the relation between machine learning and differentiation. And also, I have another point, which is computer vision. So, what is the connection between differentiation? And I want to, actually, I just want to let you know that what is the role of differentiation in machine learning and computer vision. This is my main purpose for this video. Okay, so that's why I discussed differentiation. If I don't if I not talk about only sorry, not talk about differentiation, then how would you understand that what is differentiation? So that's why I explained this one. Okay, now let me close this one, and let's go here. Hmm, wait a minute, let me erase this one. Okay, so we have understood the basic of differentiation. Now, what is a machine learning? So, before talking about machine learning, let's talk about human learning. So, I can say that many of you may heard about share market, and maybe you have invested some money over there. Someone has not, invested yet. So, if I talk about the investment in share market, and in one day, if I invest 10 rupees and the second day I get 20 rupees, okay, again I invested 20 rupees and I am getting this time 40 rupees. The third day I am going to invest 30 rupees and I am getting 60 rupees. So you can predict that this is actually double. That means whatever amount you are investing over there, you are getting double. So it's giving you profit, 100% profit. Okay, the same way, I mean, now if you predict that, you have already predicted, so you will do what? You will invest thousand of rupees, and then you will be thinking that yes, of course I will, next day I will get 2000 rupees. So this is your prediction. This is how human learns. Okay, the same manner machine also learn. Machine can also predict, but it predicts based on model. Okay, it's a fact. I mean, if you give a model to machine, then it will learn the process and it will predict based on that model. Okay, but sometimes predictions can be wrong. Suppose you invested 1,000 rupees and the next day share market is down, and what will happen? You will lose your money. So in machine learning also, sometimes it fails to predict the correct thing, and actually prediction always not right. There are some loss, or you can say error also. So here differentiation come. That means suppose you are at a high place. I mean, you are at a hill. It's very high, and now that means hill is high. That means error is high. You predicted and you got error which is very high. Now you are finding a way so that you can come downhill. So, differentiation will give you the path which you can follow to come downhill. That means you can make your error, or you can minimize your error. This will be done by differentiation. So, this is the main thing that I have already told you about the differentiation. So differentiation will help you. That means the parameter. Let me talk about. I have written something over here, and let me show you that what we do. Why programmers should care about the differentiation, about the machine learning. So as a programmer, we deals with normally input. We take input, and we after taking input, suppose you are taking input from the user like name, anything, and you are passing a value, and this will be your output. And also we define some parameter, sorry, define some function and something, and there we pass some parameters which is actually a model. Like in this question, no, you can understand that I have defined a function, okay, and I pass the parameter as x. So, and what is returning me? It's returning me x square. This is your model. Actually, you are defining, you are giving a model that yes, whenever I will give x, it should be square, always square. That means if you pass the value of x, it would be square of x. If you pass the value of x as 3, then it would be 9, because the square of 3 is 9. This is your actually model that you are going to provide to machine, that yes, you have to predict on this model. So actually this is not, I'm just trying to make you understand. Okay, so this is something. And now differentiation tells you which parameter caused how much error. That means it will tell you that yes, you should choose this path so that you can come downhill. That means you can minimize your error. Okay. You have seen machine learning, the use of machine learning in everywhere. I mean, in your email also, you have sometime maybe you have noticed that you got some spam messages. I mean, you are getting some messages and it's already going to save in your spam. Why? Because machine is going to learn that yes, in this email there is something which is not related to you, which you have never used, and which is not very common thing to talk about. That's why it learns, and it's going to store that email into spam. And also this you maybe you have noticed that in WhatsApp you have option called spam. If you are going to block someone, then you have option that you can put it into spam. Or in call also, if some suppose you got a call and you didn't receive, or maybe you have received, then you have option, you can go to the YouTube call or anywhere and you can put that number into spam. So that means whenever this call will again come to you, your mobile will not ring. And after ending the call, you can see that yes, there you got a spam call. You can try it to your friend. I mean, you can put your friend's number in spam, and then when your friend will call you, and you will not get the at the moment when he will call you, you can not hear the ring of your mobile. But after ending the call, it will be you can see in your mobile that yes, there is a spam call. So this is how machine learns. Okay. So let me. I have already run this code. Let me comment this one. Okay, we have already talked about the machine learning. Hmm. Now let's talk about the. Oh, okay, sorry. Let me talk about the gradient descent in the machine learning. This is actually a heart of machine learning. What is this? Let me. Yes, this is the code for machine learning. Sorry, the gradient. So here, W is weight, and I have taken a function called loss, and I'm passing the weight over here. W is my weight. Okay. Uh, Wait a minute. First, let me talk about the variables what I have taken. W and LR. What is W? W is weight, and LR is learning rate. So you can see that I have the function which I have defined, which is loss. It's going to return me the this equation actually. You can see the value, which is W minus 5 to the power, I mean the whole to the power square, and it will be, if I put W as 5, then what will happen? This will give you 0, because 5 minus 5 equal to 0. Then square of 0 is also 0. So it is going to give you 0 when W is equals to 5. That means this will be your minimum. Okay, and if you want to put the value of W as 6, then it will be 1. If you put 7, then it would be 4. Okay, in this way it will increase. So right now I'm putting W as 0 and learning rate as 0.1. Then I want to perform iteration. This is my actually iteration. Okay, I'm performing iteration. So what I'm doing, I have decided a range from where? Range from it will start from 1. Actually not from 1. It will start with 0 and it will end up to 19, because whenever we take a range, it will always, actually this is a lower bound is lower, it will take the lower bound but it will not take the upper bound. That means 0 is including, but 20 is exclusive. That means it will not going to take the 20 value. If you want to take up to 20, then let's take it 21. Then it will be, you will get from 0 to 20. Okay, so what will happen? I'm taking this value. Wait a minute. Okay. So I, you know that I have defined the function over here, and it is going to return me this one. And here I have, what I'm doing is I'm taking again this one. I'm using the W, I mean 2 into W minus 5, which is coming from I have defined this equation over here, and I'm going to store it into grade, I mean into a variable called grade, or you can say reference called grade. Okay, now what will happen? Just try to understand it in a simple way, that this is a simple calculation actually. If you don't go for this iteration, wait a minute, okay, wait a second. If you don't think about this one, then what will happen? You can simply say that yes, you have a variable called grade and you are putting the value in this grade. Okay, Suppose you, this is x and this is a value of x, okay, I mean the equation for x, and what and then w is again x. Suppose this is x and we are doing what, x minus lr into grade. This grade is going to, okay, let me write it into in this way, that okay. So I'm going to write, suppose we have x. Oh, don't talk about x. Let me take it y. Y equals to, you have 2, okay, and 2 into your w minus 5. Okay, this is something. And then you have something like a w equals to w minus lr, which is learning rate. Let me take it as a z, okay, into the grade is I have taken as, sorry, as y. Okay, so this will your simple equation, and this equation will return you, I mean when you go to run this with the help of iteration, that means again in the first iteration it will take the value as 0. Okay, 0 for, okay, before talking, let me run the, let me execute the program, then it will be easy to understand for you. So you can see that step 0, that means when the step is 0, that means when the value of I is 0, then what is happening? I have already taken W as um, 0 over here, but now I'm putting this value over in this equation first, and then whatever value I will get, it will be stored in grade, and now I'm using this grade over here. Okay, so let me show you that what is going to happen. So first it will store over here, and then I mean suppose w equals 0 and lr equals 0.1, then what will happen? W minus 5, so it will be 0 minus 5, and then it will going to show over here, which will be nothing but yes, it will be minus 10 actually. Okay, so grade will be minus 10, and now I'm putting this value minus 10 over here, and I have lr 0.1. So it will be, okay, let me write this now, because you maybe can face some problem solving it. Okay, so if I talk about this one, that means the grade, grade, grade would be, sorry, not grade, it's grade would be your minus 10 actually. It would be your minus 10. Hmm. Then if I put it in this equation, then what will happen? So it will give you W equals to, I'm going to take it W as a W, okay, and minus LR is 0.1, so it would be 0.1, okay, oh, what, 0.1 into bracket minus 10, okay, but I write written minus 10. So what will happen? It will multiply, and minus minus will be plus. That means um, it would be your 10. So let me check the answer. W is 1. Actually, sorry, it will be 1. So W will be your 1. You can see the value W is 1. So here you can, in this way you can calculate. Actually, don't count for, don't think that this W and this W will cancel out. No, it's not going to happen, because this is not the mathematics. I mean, we are not talking, we are not doing it on a paper, and actually this is not the mainly mathematics. We are doing it in a programming. So it is W is, it's a variable that we are going, where we are going to store this value. Okay. Oh, sorry. Actually, you can also put the value of 0 W as 0 over here. This W and this W are not same. Let me tell you. Okay. These are not same. So I'm going to put the value of W as 0 over here. Then it would be your the complete answer would be 1. So in this way you can calculate it. Okay. And when the I would be 1, then again the new value you are going to get it. Okay. Hmm. So this is called something called gradient descent. That means in this way you can minimize your error. This is exactly how neural network. I have introduced this word neural network, but we will talk it talk. some other time, because this is otherwise it will be very complex to understand for you. So we have talked about the differentiation, we have talked about the machine learning, and we also I have also told you the relationship between I mean the role of differentiation in machine learning. Now the time for computer vision. So let's start computer vision. What is computer vision? Computer vision is nothing but machine learning plus images. मतलब we have, I mean, we will do some prediction. Okay, we will calculate error and we will minimize the error. We will do everything like we did in or we do in machine learning. And plus we will talk about the images. What is images? Images is nothing but a numbers, number of pixels. That means you have maybe noticed, or we always click pictures and you can see over there are some pixel like for 20, 40, 50, 60,000, anything. It can be anything. So this is a number, and this is it can be a huge number also. So in images, we need to also focus on edge. Edge means the corner of, you can say, the corner of your image, how it would be. So edges is nothing but where pixel values changes sharply. I mean, you have to define that. Let me suppose I have a picture. I have a picture like this. Okay. So this is one picture, and you can see this is my age. There are four ages. So it will the ages do what? This take that, yes, how sharp your age is, or how it's going to change. Okay. Let me remove this one. Okay. Hmm. So ages is like this one. That means we actually in computer vision we learn about images, about a matrix, because pixels use I mean you can do with the help of matrix you can understand the pixels, or you can uh, mm, I mean you it will be easy to understand if you know about matrix. I will discuss matrix also in some other video, but for the time being just listen that yes, we use matrices when pixels come, matrix also come. Okay. And differentiation do what? Differentiation will help you to. I just said that in if you have an image, then the age, how sharp your age will change, it decided by differentiation. Differentiation change, I mean, it will decide that yes, your sharpness of your edges would be like this one, so that it would be understand. I mean, actually in here also there is some point, there is a point called CNN, and this is a new term which I'm going to introduce in this video. I mean, this is new to you and new to me also. Okay, CNN is nothing but convolutional neural networks. It's usually used for pictures, because we are talking about computer vision, that means the images. So this is normally works for images. Okay. So it filters and it check the weight of the image. Okay, this is a simple thing. I just try to understand over it. Okay. And uh, if only you work with CNN for a image, then you will not get your desired uh, image or desired result. But if you use differentiation, then you will be able to so many things, like you can handle the pixels, you can handle the big number, and you can also handle the edges of your image. Okay. If you not use differentiation, then CNN will not be I mean this will not be useful for you. And also no object, you cannot detect the object, and also you cannot recognize the face of your image. Suppose you are showing an image of dog, okay, and it predicts that it is a cat. So do you think it will be okay? No. If you use differentiation, then it will be predicted. It will predict, I mean, it is based on the weight of the image, based on the pixel, based on the ages. So if you use differentiation, then you can be able to detect the image, the face of the image, the object. So this is the main purpose of differentiation in computer vision. I hope it's clear. If there is any doubt, then you can comment. You can comment out, and I will tell you. I will explain you again. Okay. This is not a complex topic, but if you think that it is complex, then it will be complex. So don't think complex, okay? And stay happy and healthy and keep practicing. In the next video, we will discuss new topic.